Hello students, I am Dr. R. Krishna Kumari, Assistant Professor, Department of Mathematics, SRM Institute of Science and Technology, Katangulattur. Today we are going to see few topics in vector calculus. Let us see the outline of this module. Today we are going to see what is meant by divergence and curl of a vector function, followed by the vector identities. Then we are going to see about solenoidal vector, and at the last we are going to see about irrotational vector and scalar potential. Divergence of a vector function. If f vector x comma y comma z is a continuously differentiable vector point function in a given region of space, then the divergence of f vector is defined by dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, where f vector is equal to fn I vector plus f2 j vector plus f3 k vector, and divergence of f vector is a scalar point function. Curl of a vector function. If f vector x, y, z is a differentiable vector point function defined at each point x, y and z in some region of a space, then the curl of f is defined by the cross product del and f vector, that is the determinant I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3, where f vector is equal to f1 I vector plus f2 j vector plus f3 k vector. So we have to remember that the divergence of a vector function uses the dot product and curl of a vector function uses the cross product concept. And we have to also note that the curl of a vector function is a vector point function and the divergence is a scalar point function. Now we are going to see sums based on the divergence and curl of a vector function. So if r vector is equal to xi vector plus yj vector plus zk vector, then find divergence and curl of r vector. So given r vector is equal to xi vector plus yj vector plus zk vector, then to find the divergence of r vector, we are going to use the dot product concept. So divergence of r vector is equal to del into r vector, so which is nothing but dou x by dou x plus dou y by dou y plus dou z by dou z. So we will be getting the answer as 1 plus 1 plus 1, which is going to be equal to 3. Now to find the curl of r vector, we are going to use the cross product concept. So del into r vector is equal to determinant of I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and the third row is going to be equal to x, y and z. So by finding the determinant, we will be getting the value as I vector into 0 plus j vector into 0 plus k vector into 0. So which is going to be equal to 0 vector. Find the divergence of grade of phi and curl of gradient of phi at 1 comma 1 comma 1 for phi is equal to x square y cube z power 4. So given the value of 5 as x square y cube z power 4. So to find the gradient of 5, we know the formula which we have seen already in the presentation of vector calculus part 1. So del phi is going to be equal to I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. So now we are going to differentiate x square y cube z power 4 with respect to x and with respect to y and with respect to z. So by differentiating, so we will be getting del phi's value as I vector 2x y cube z power 4 plus j vector x square 3 y square z power 4 plus k vector x square y cube 4 z cube. So thus divergent of gradient of phi is going to be equal to the dot product of del into gradient of phi. So which is going to be equal to dou by dou x of 2x y cube z power 4 plus dou by dou y of x square 3 y square z power 4 plus dou by dou z of x square y cube 4 z power 3. So now by differentiating the first term with respect to x, the second term with respect to y and the third term with respect to z, we will be getting the answer as 2y cube z power 4 plus 6x square y z power 4 plus 12x square y cube z power 4. Now by applying the values as 1, 1, 1 in the place of x, y and z, we will be getting the value for divergent of grade of 5 as 2 plus 6 plus 12, which is going to be equal to 20. Now to find the curl of gradient of phi, we are going to use the cross product concept, that is the determinant I j k dou by dou x, dou by dou y, dou by dou z, 2x y cube z power 4, x square 3 y square z power 4, x square y cube 4 z power 3. So by simplifying this determinant, we will be getting the answer as 0 vector. These 9 identities are some important vector identities. In all these 9 vector identities, the dot product concept and the cross product concept is used. So these vector identities are very useful for solving 1 mark questions. Now let us see what is meant by solenoidal vector. A vector f is said to be solenoidal if divergent of f vector is equal to 0. That is, the dot product of del and f vector is equal to 0. Now let us see a sum based on solenoidal vector. Show that the vector f vector is equal to 3y power 4 z square I vector plus 4x cube z square j vector minus 3x square y square k vector is solenoidal. So they have given that f vector is equal to 3y power 4 z square I vector plus 4x cube z square j vector minus 3x square y square k vector. So to prove that the dot product of del and f vector is equal to 0, we have to differentiate with respect to x, then with respect to y, and then with respect to z. So dou by dou x of 3y power 4 z square plus dou by dou y of 4x cube z square plus dou by dou z of 3x square y square will give the value as 0 plus 0 plus 0, which is equal to 0. So since we got the answer as 0, it is proved that f vector is solenoidal. If f vector is equal to x plus 3y I vector plus y minus 2z j vector plus x plus lambda z k vector is solenoidal, then find the value of lambda. So here they have given that f vector is solenoidal. So we have to find the value of lambda. So since it is given that f vector is solenoidal, the dot product of del and f vector is equal to 0. So we have to put the given equation as equal to 0. So by putting the given dot product of f vector del and f vector as 0, we will be getting an equation as dou by dou x of x plus 3y plus dou by dou y of y minus 2z plus dou by dou z of x plus lambda z equal to 0. Now by differentiating the first term with respect to x and the second term with respect to y and the third term with respect to z, we will be getting the value as 1 plus lambda equal to 0. Therefore, lambda is equal to minus 2. Now we are going to see what is meant by irrotational vector and scalar potential. A vector is said to be irrotational if curl of f vector is equal to 0. That is, if the cross product of del and f vector is equal to 0. And if f vector is an irrotational vector, then there exists a scalar function phi such that f vector is equal to del phi. Such a scalar function is called a scalar potential of f vector. Now let us see sums based on irrotational and scalar potential. So show that the vector f vector is equal to 6xy plus z cube I vector plus 3x square minus z j vector plus 3x z square minus y k vector is irrotational. So they have given the value of f vector. To prove that curl f vector is equal to 0, we have to prove that the cross product of a del and f vector is equal to 0. So by using the cross product concept, that is by using the determinant concept, we will be arriving at the answer such that I vector is equal to minus 1 plus 1 minus j vector is equal into 3z square minus 3z square plus k vector into 6x minus 6x. Obviously we will be getting it as equal to 0 vector. Therefore, f vector is irrotational. Prove that f vector is equal to y square cos x plus z cube I vector plus 2y sin z minus 4j vector plus 3x z square k vector is irrotational and find its scalar potential. So first we have to prove that the given f vector is irrotational and then we have to find its scalar potential. So to prove that it is irrotational, we are going to use the cross product concept. So the cross product of del and f vector is going to be equal to I vector into 0 minus j vector into 3z square minus 3z square plus k vector into 2y cos x minus 2y cos x. So obviously it is going to be equal to 0 vector. Thus we have proved that f vector is irrotational. Show that it is scalar potential. That is, we have to find the value of the scalar potential. So to find phi such that f vector is equal to del phi. So we know that the formula for del phi, that is the gradient of the gradient phi is equal to I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. So by equating the coefficients of I vector, j vector and k vector, we will be getting dou phi by dou x as y square cos x plus z cube, dou phi by dou y as 2y sin x minus 4 and dou phi by dou z as 3x z square. So by integrating the above equations partially with respect to x, y, z respectively, we will be getting 5 as 5 equal to y square sin x plus z cube x plus f1 y comma z, and 5 as y square sin x minus 4y plus f2 x comma z, and 5 is equal to x z cube plus f3 x comma y. Therefore, 5 is going to be equal to y square sin x plus z cube x minus 4y plus c is a scalar potential. So this is going to be the end of the module. Thank you, students. Let us connect again in a next interesting topic. Thank you.